Electric and hybrid vehicles and large wind turbines rely on strong permanent magnets to work efficiently, and rare earth metals make the best permanent magnets in the world. But supplies of rare earths are becoming tight. Today, 95% of rare earths come from China. More supplies will be coming online soon, including some from this rare earth mine, located on the eastern edge of California's Mojave Desert. The reopening of this mine, owned by the company Molycorp Minerals, will help alleviate some of the supply problems, as will other new mines in Australia and elsewhere. But these new supplies may not be sufficient to meet booming demand for some rare earths, including neodymium and dysprosium, which are needed to make motor and turbine magnets. Molycorp's main product, a mixed rare earth oxide called didymium, does contain one of the major magnet elements, but not the other. Part of the problem is that magnetic alloys based on rare earth metals, including neodymium, are so good no one has put much effort into alternatives for decades. One major exception to this in the United States is the Ames National Laboratory in Iowa, where researchers are working on several alternative materials, as well as new manufacturing methods for using the rare earths we do have much more efficiently. In his office at the Ames lab, scientist Ivor Anderson plays around with two small neodymium magnets to show how strong they are.
I can support it through my hand, and that's the magnetic flux basically passing through my hand. So that's how strong these things are. But it's kind of an illustration of why actually it's well worth trying to develop better rare earth permanent magnets, or to develop magnets that would come close to the strength level.
This is a magnet that contains no rare earths. Anderson and his group are tinkering with the structure of this material, called alnico, to see if they can make it strong enough to create torque in a motor. The Ames researchers are also working on new ways of making rare earth permanent magnets that are strong enough for motors but use the rare earths more efficiently. One possibility is to make magnetic particles that can be mixed with plastic and injected into molds. This type of magnet isn't strong enough to run motors today, but making magnets this way wastes less material than the sawing techniques necessary to create motor magnets of the right shape. Ames scientist Bill McCallum explains that the first step is a process called melt spinning, which is used to create ribbons of magnetic alloys that will then be crushed before putting together to make magnets.
So we put the power into the metal, we melt it. We then pressurize it. This wheel is spinning at a rate of about 60 miles an hour surface velocity. And so we put a stream of metal down onto there. It rapidly solidifies and comes out as ribbon.
Ribbons of this material are crushed before being formed into magnets. The Ames researchers expect they're at least a few years away from making magnets that are strong enough to rival the rare earths. What will happen as supplies tighten in the meantime is anyone's guess. This is Catherine Borzak, Technology Review's Materials Science Editor.